Welcome, everyone. Good morning, and thank you for coming to our informational meeting today. This is the California Department of Fish and Wildlife's public informational meeting on the draft study plan for the in-stream flow evaluation for Clear Lake Hitch Passage in tributaries of the Clear Lake watershed. My name is Brianna Drescher, and I am a senior environmental scientist with the CDFW's water branch, and I am joined here today with Diane Haas. She's also going to co-facilitate with me, and she's also from Water Branch. And we will be starting the meeting just momentarily. There's other folks here from our regional office and our headquarters office as well, and I'll introduce them in a moment. So the format of today's meeting, should we go? This is a Teams broadcast, so in the broadcast format, the audience unfortunately is automatically muted. However, on the right side of the meeting, you will see a Q&A box. So as we go through today's presentations, please submit your questions, and Diane will provide as much information as she can and links as we go. And then at the end of the meeting, we'll spend the remaining time answering as many questions as possible that were not already handled in the chat. If we are unable to get to your questions today, please feel free to reach out to us at instreamflow@wildlife.ca.gov, and we will be happy to make sure everyone's questions are answered. Today's presentation is going to start with Nathan Cullen from our North Central Region office, and he's going to provide some background information on Clear Lake Hitch. Then Felipe Laluz will follow with a discussion on the status of the Clear Lake Hitch and current and ongoing conservation and coordination efforts that are underway. And then finally, Jenna Rindy from CDFW's Water Branch will present an overview of the draft in-stream flow study plan. After that, we will wrap up today's meeting with some next steps and then go through the remaining time with whatever questions we can get to. So before I hand over the meeting to Nathan, I just want to make folks aware of our department's mission, which is to manage California's diverse fish, wildlife, and plant resources and the habitats upon which they depend for their ecological values and their use and enjoyment by the public. So with that, I will hand things off to Nathan Cullen.
Hey, good morning, everyone. My name is Nathan Cullen. I'm an environmental scientist with the California Department of Fish and Wildlife in the North Central Region, Sierra Fisheries Unit, and I'm focused on restoration of the Clear Lake Hitch. So the scientific name for Clear Lake Hitch is Lavinia exilicauda chai, or commonly known as chai. Next slide. This species is endemic to Clear Lake watershed, meaning that it occurs in Clear Lake and its tributaries and nowhere else. They were once extremely abundant, numbering in the millions of individuals historically, and they also supported a subsistence fishery in the Clear Lake region for native Pomo tribes. And interestingly, the hitch functions as an indicator species, meaning that it's able to serve as a measure of the environmental health in the environment that it lives. The hitch is in the minnow family. You think of minnows as fairly small fish, but this one happens to be able to grow quite large. It's actually a subspecies of the Sacramento hitch, and the Sacramento hitch inhabits the Central Valley of California, the Sacramento River and San Joaquin River watersheds. They tend to have about a 5 to 6 year lifespan, and females mature and reproduce in about their 2nd to 3rd year of life. As you can see from this photo, the maximum size of hitch is about 14 inches. So here's a huge word for today. Hopefully everybody will remember this. It's Potamodromus, which means that this species basically spends its entire life in fresh water. They do tend to migrate from Clear Lake up into the tributaries to spawn, and thus access to tributaries increases the amount and quality of spawning habitat. The species actually requires different optimal habitats for growth, survival, feeding, and reproduction. And they are very much, they utilize tules and other submerged aquatic vegetation for cover. So hitch are not strong jumpers by any means. If you think of a salmon or a steelhead that can jump up falls and riffles or through step pools, this species really can't do that. So at lower flows in the tributaries, depth becomes a limiting factor. They can be found schooling up at the mouths of tributaries when water temperature hits about 50 degrees Fahrenheit. And migration typically takes place between February and May, but it can continue into summer. So spawning habitat for the species is ideally clean gravel substrate and at water temperatures between about 57 to 64 degrees. They are not obligatory stream spawners, meaning that they don't have to spawn in the streams. They also have been observed spawning at the lake shore. Spawning is typically done in very shallow areas, either of the tributaries or on the shore of the lake, and they'll utilize deeper pools nearby as a holding or resting habitat. It's important to note that spawning is very much limited during drought years. So when there's a lack of precipitation, the species isn't, they're not getting the right signal to go upstream and do their thing for spawning and recruitment. So after being laid, the eggs will hatch within about 7 to 10 days, and fry become free swimming after another 7 to 10 days. Juveniles will migrate or out-migrate down the tributaries to the lake at about a month old before these streams dry up. And both juveniles and adults feed primarily on macroinvertebrates, including insects and zooplankton. And interestingly, juvenile clear lake hitch used to be sold as a bait fish. So there's a variety of threats to the species. Right at the top of the list is reduced flows within the tributaries that they require for spawning, as well as a loss of habitat diversity, which is super important for reproduction and recruitment. There's also a lack of habitat connectivity due to dams, diversions, and things like road crossings, as well as ecosystem disruption, which is caused by warmer summers, prolonged droughts, and a lack of precipitation. Other threats include a variety of predators that consume them. So you can think of bigger fish, raptors, raccoons, shorebirds, as well as predation from invasive and introduced species. So carp and goldfish will swim up the tributaries during hitch spawning and have been observed eating eggs and larvae. They'll also feed on any eggs that have been deposited during lakeshore spawning. So we conclude that streams basically function as better spawning habitat for recruitment because there's fewer predators in comparison to lakeshore spawning. So the species hasn't been studied very well by science. There's quite a few unknowns. And at the top of that list is, there's a variety of research that's needed to better understand their ecology and life history, such as we don't really understand their swimming ability for passage over riffles and barriers. We don't really know what exactly suitable water velocities are for them to migrate and spawn in, as well as specific water temperatures, substrates, or migration triggers. So required duration of sustaining flows for egg development is something that we don't understand, as well as when the larval individuals start to emerge, and kind of their timing for downstream migration before the streams dry up. Other things that we don't really know about the species, we're going to need to do some research to determine what the adequate flows are within the tributaries for Clear Lake hitch passage, to try to understand what is ideal timing and intensity of flows, as well as what stream sections function as barriers during low flows. And hopefully all this will go towards helping to guide and support management actions of water resources and flood control operations. And next, I'll pass it off to Felipe Laluz.
Thank you, Nathan. My name is Felipe Laluz. I'm a senior environmental scientist in the department's Native Fish and Conservation Management Program, and I facilitate the Clear Lake Hitch Task Force. Next slide, please. So I'm going to give you a little overview of some of the recent history, starting with the listing history. This subspecies was petitioned for listing under the California Endangered Species Act in 2012 by a petition brought by the the Center for Biological Diversity in collaboration with several sovereign nations from the region. The commission listed the species as threatened in 2014, and as part of this listing process, the department develops a species status assessment or a species status review, which was published in May of 2014. Within this review, you can find more details about some of the threats that Nathan discussed earlier. More specific to this study, to the in-stream flow study, the review identified migration barriers, habitat loss, and reduced flow and early drying of streams as a subset of the threats that this species faces. I'll also note that the U.S. Fish and Wildlife Service is reviewing the species status currently for potential listing under the Federal Endangered Species Act. Next slide, please. The tribal governments have really driven a lot of the action, not only in providing testimony and motivation for the listing, but more recently came to the Fish and Game Commission meeting and provided public testimony, really reminding us of our obligation to conserve this species. In 2022, in summer of 2022, the department entered into a government-to-government consultation with the sovereign tribal nations. One of the outcomes of this consultation was the formation of a multi-agency task force in which we're bringing together state, local, and federal entities to really address the many threats and challenges that this species faces. We also convened an emergency summit in December of 2022 that allowed tribal and agency leadership to really get together and have some frank discussions about what next steps forward. We did have a follow-up summit in 2023 and are planning a 2024 summit to continue the conversation. Last year in 2023, as a response to the summit, we've really enacted a lot of efforts, including supporting existing efforts such as the monitoring both within the department and by tribal EPAs, environmental protection agencies, and as well as the United States Geological Survey, whose data is really important to how we assess these species. Some of the new efforts that have come about are improved outreach. This meeting is an example of that. We also attend various Board of Supervisors meetings and other public forums, such as the Fish and Game Commission and the State Water Resources Control Board's hearings, to really inform decision-making on this. We also participated in a Lake County Farm Bureau event recently. The Farm Bureau invited us out to give scientific presentations to the public. It really had a good good turnout, and really appreciate the Farm Bureau's efforts. We are providing funding and coordinating barrier removal, barriers being a big issue that's been identified and talked about recently. These barriers can be in the form of soft barriers. I'm sure some of you have seen the California Conservation Corps out there clearing brush and doing some stream bed maintenance, but we're also trying to tackle larger barriers along with the county. And we're supporting new science, both in the form of research by agencies and supporting the scientific programs and the good science that the tribes are doing. Next slide, please. Just an overview of some of the recent population observations. 2023 was an extremely wet year, and this improved the connectivity and habitat, and it's reflected in the data that we collect. I will point out that these surveys do not sample larval fish, so we won't get an understanding of how the 2023 cohort responded to this year when they are big for us to cover. We did see juvenile and adult observations, both in our electrofishing and in the visual surveys conducted by the department. And this is reflected also in the USGS data and observations by the tribal science programs. And here we see a substantial in the electrofishing relative population estimate, this plot on the left. We see a substantial increase This estimate is not a hard number. It's an index that we'll use to track over time the progress, and there were some very wide error bars associated with this number. So the higher number was about 1.3 million. That does not literally translate to there are 1.3 million fish in the lake. It's a relative index. As far as the visual surveys, this survey monitors tributaries in Big Valley. And here we did see an increase in observations of adults moving into these tributaries to spawn. Next slide, please. One of the existing efforts that we're trying to wrap up and get a signature on is the draft conservation strategy. This document is available on Lake County Water Resources Department website. And within that draft conservation strategy, we have a population target. We're still working on some of the nuance of this population target, but it does give us a good goal to shoot for. It's based currently, in its current iteration, is based on the 3 CDFW surveys, so the visual survey, the relative population estimate, and the general fish survey. And for that population target to be satisfied, all 3 of these criteria will need to be met for 6 consecutive years. We did see increases in fish, as I said, in 2023. However, the visual survey numbers reported did not meet the criteria, which is 8,360 fish observed. The relative population estimate and fish survey both did meet that criteria, but did not count towards the 6 consecutive years included in our draft population target. Next slide, please. Just a little more information on the task force. These are our current collaborators, and we are expanding bringing in more government agencies and also bringing in more tribal governments. Some examples of some of the great work that's come out of the task force: the State Water Resources Control Board has done an extensive amount of outreach to describe the information order that many of you have heard about. We've really improved our data sharing both with USGS and with the tribal governments so that we all get good information as it's made available. We get updates on the Middle Creek project, updates on the California Conservation Corps work, Bureau of Land Management. All of these entities are really contributing to this complex web of issues that are affecting Clear Lake Hitch. Next slide, please. So that brings us, just to narrow the focus back down to why we're here today. We're here to talk about this in-stream flow study. Big Valley Rancheria conducted the first study of this kind for a non-salmona. The department's been doing studies of this sort for quite some time, typically focusing on salmon and trout. So Big Valley led the way in expanding this type of study to non-salmoniid fish, and this is the first time the department is actually conducting one of these studies for a native minnow. So this study is to complement Big Valley's study and really build on it. This came about from Executive Order N523, which was signed by Governor Newsom in March of 2023, and it directed the State Water Resources Control Board and the CDFW to in-stream flows to protect. And with that, I'll hand it off to Jerry to the details of the study.
Thank you, Felipe. Next slide, please. Hello, my name is Jenna Rindy. I am a Senior Environmental Scientist Supervisor in the In-Stream Flow program found in the Water Branch of CDFW, and I will be going over the draft study plan. Next slide. I'll be providing a high overview of what we'll be discussing, including our goals and objectives, our watershed components, study approach, hydrologic analyses, two-dimensional hydraulic habitat modeling, quality assurance and quality control, and overall our next steps. Next slide, please. Our study and goals, study goals and objectives are listed here. One of our goals is to identify flows needed to maintain Clear Lake Hitch passage and tributaries of the Clear Lake watershed. We will do this by coordinating and collaborating with all of our partners. We'll also identify habitat maintenance flows for tributary streams. Next slide, please. I do want to acknowledge that watershed systems are highly dynamic and complex. Our study will focus on fish passage or passage for the Clear Lake hitch. This is just one piece of a much larger puzzle. And to do this, we will work closely with our partners to make sure we're collaborating, coordinating, so we can help try to solve this much larger puzzle. Next slide, please. Our study approach is we worked with the task force that Felipe mentioned. And with the task force, we identified 6 creeks as illustrated in the map on the left. And the 6 creeks, I must say them from top left to bottom right, are Mill Creek, Scotts Creek, Manning Creek, Adobe Creek, Kelsey Creek, and Coal Creek. We classify the sub-watersheds following the United States Geological Survey's hydraulic unit codes. Additionally, we will build 2D hydraulic habitat models in selected reaches of these tributaries. As Felipe mentioned earlier, we'll be using, there have been previous studies done by the Big Valley Band of Pomo Indians Environmental Protection Agency, so we will be using the same depth and velocity criteria used. And we do realize that these are just 6 tributaries of a much larger watershed. And to account for this, we will also complete hydraulic analyses. Next slide, please. And by doing these hydraulic analyses, we'll gain a better understanding of the entire watershed perspective. To do this, we'll be utilizing existing gauge data. We'll be using another tool from the Natural Flows database to estimate as an indicator of unimpaired flows. And then lastly, we'll use a functional flows analysis, which I will explain all of this further. I do want to acknowledge that these tools are adapted from the California Environmental Flows Framework. For more information, the link is here. Next slide. Okay, so a lot going on in this image. What I'm trying to convey on the image on the left, this is just one gauge located in the Clear Lake watershed. It's a USGS gauge, Kelsey Creek near Kelseyville. On the left, where there's the green triangle, is where it's located. The reason why we selected this gauge is because it has the longest period of record. It has been around since 1946 and is currently going. From this, the image on the right is what I kind of want to focus on now, which explains some of the data. I'm going to zoom in into the notice the scale, I think, goes from 0 to 3,000. I'm going to zoom into 0 to around 300 CFS. Next. And this will help us understand the trends, or just kind of visualize the trends a little bit better. And so what I want to show is that the wettest year is shown in blue, which occurred in 1983. The median year occurred in green, that occurred in 1962. And the driest year in the record occurred in 1977. Note that the X scale is based on water year. Water is based on the full water year from October 1st through September 30th. And then the y-axis is discharge in cubic feet per second. This system is highly flashy. And so this kind of, by looking at the high or the wettest and median and driest year, really kind of helps us understand the variability going on in the system. Next slide. Another tool we use is the Natural Flows database. This helps us estimate unimpaired flows. It's a great tool from the Natural Flows database. Essentially, it's a statewide model that can predict unimpaired flows at every stream reach in California. And again, this just really helps us understand unimpaired estimates of what's going on in the watershed. Next slide, please. And our next tool is a functional flows analysis, which we will use existing gauge data and also the modeled estimates of unimpaired flows. Overall, this helps us understand natural flow patterns in the watershed that are ecologically significant. In California, experts have identified 5 functional flow components, and each of them is highlighted in the image, and I will walk through it closely. First is the fall pulse flow. This is the flow, the first major storm event of the new year. Next is the wet season peak flow, occurs during and after the largest storm events of winter. Next is wet season base flow, is the elevated base flow between the winter storm events. Next is the spring recession flow, the transitional period between the wet season and the dry season. This is important for the Clear Lake hitch's spawning, juvenile rearing, and out migration period. And then lastly, the dry season base flows, where there is either low flow or no flow in during periods of California. And next slide, a functional flows approach helps us support geomorphic dynamics and ecological functions. Sorry, one moment here, getting caught up. It helps us identify natural flow regimes, including the magnitude, frequency, duration, timing, and rate of change in each of those metrics, or each of those functional flow components. And overall, these metrics help us characterize and quantify flows that help support overall ecological function and health. Next slide. Our next tool or method that we will be using is 2-dimensional hydraulic habitat models. We work really closely with our senior hydraulic engineers in the department. Essentially, it is a model to assess fish passage over a defined reach of stream. We can simulate a variety of flows, whether they're high, medium, or low flows, to help us understand fish passage. To do this, we define an area of interest. If you look on the figure on the left, flow is going from right to left. Right is being the upstream boundary, and left, where the red line is, the downstream boundary. Then we overlay a grid over this, and in blue is the wetted area of the channel, and in white is there's no water present. And in a given cell, we can then predict flow and velocity in a given cell. To kind of help us get all the data needed to build these models, we use a variety of tools, with the first being LiDAR. Next slide, please. LiDAR is short for light detection and ranging. Essentially, it's a remote sensing method that uses light in the form of a laser to measure ranges or distances from Earth. This provides us topographic data that really helps us get a better understanding of the elevation of the surface of the Earth. On the left, I really like this diagram. It's from the USGS, kind of explaining just a high overview of what it entails. It's using an aircraft that uses a green laser. We call it green LiDAR. And what's important about that is that LiDAR, it can penetrate the water surface. And so we can really get an understanding of the bathymetric data. And our plan will be using really high resolution, so we can really understand from the Clear Lake hitch's perspective when we're building these models. Next slide. Additionally, we will be out in the field collecting data. The image on the left is of our team collecting topographic data. This will help us where LiDAR resolution may be limited. The middle image is one of our staff collecting water surface elevation. And on the right is our team collecting discharge measurements. And together, those will help us calibrate our model. Next slide. And then to build a 2D model, we will take the input of the topographic data, whether it's from LiDAR or if it's from our team collecting it, which is a graphic on the top right, top right image is an example. Then we'll create a digital terrain model, the middle image. And then from our model, we can run simulations and have output of continuous depth and velocity measurements, which the image at the bottom is an output example of depth. Next slide, please. I want to highlight that we use standard methods that are defensible. Our standard operating procedures are all available on our website. Additionally, we have a quality assurance program plan that describes in detail our program management, data generation, assessment and oversight, data validation, and usability. This follows the US EPA QAPP guidelines to ensure that the project or study produces reliable data that can meet the needs of study goals and objectives, which we have previously listed. Lastly, I do want to recognize that we stay up to date on the existing literature, methodology, and tools similar to the California Environmental Framework that I mentioned earlier. Next slide. What's happening next is we will be doing the study in the field work this year, starting it. We will be working on developing and simulating our 2D models. Once we're ready, we'll be releasing a technical report that will detail all aspects of the study, including the study results. And overall, we will just continue to coordinate and collaborate with our partners, including California, Native American tribes, local, state, and federal agencies. Next slide. Throughout the presentation from Nathan, Felipe, and myself, we gave some references. Here are them for if you want to look in further. And with that, next slide. I will pass it back to Brianna. Thank you.
Thanks, Jenna. I just wanted to remind people too, if you have any questions, to go ahead and submit those now into the Q&A box. We're gonna go over those in a few minutes. And so yeah, the next steps for the study plan process is that our draft study plan will be located on our website by later this afternoon. And once that's available to the public, we'll start a 30-day public input period. So if you'd like to review the study plan and provide us any feedback, you can email that to instreamflow@wildlife.ca.gov by March 7th. If you have any questions about the study plan and you want to contact Jenna directly, her information is here at jennarindy@wildlife.ca.gov. We actually haven't received any questions in the Q&A, so I will give folks another minute to do that. Otherwise, feel free to email us, after this presentation, after you've had a chance to look at the study plan. If you want to also email questions to the InStreamFlow@Wildlife address, that's totally acceptable as well. We're happy to provide any clarification or answer any questions after the fact. So I will just leave this here so everybody can get the information. And then if we don't see any questions, we'll go ahead and wrap it up, but I will give it another minute or so. Thank you all for taking time out of your day to join us here and hear about the efforts that we're working on from the department for the Clear Lake Hitch watershed. And we are excited to be working on such an important project. So with that, I will give you all another 15 minutes back before lunchtime. Thank you again. And like I said, please feel free to email us at InStreamFlow@Wildlife if you need anything. Have a great day. Thank you.